Welcome to this very special episode of Science, Policy, and Politics. My name is Gregg Braden. I am your host for this entire episode, the entire series. You are stuck with me, at least for the remainder of this episode. And I'm doing my very best to keep these episodes concise, maybe 20, 25 minutes, because I want you to stay with me for those 20 or 25 minutes. I don't want to saturate you with too much Gregg all at once. You know, when we launched the first episode of the series, I got a lot of correspondence, as you can imagine. People were asking questions like, why the series? Why have I created Science, Policy, and Politics? It appears to some people to be very different from what I've done in the past. I'm a multidisciplinary scientist, a multidisciplinary researcher. I have a lot of irons and a lot of fires. Some of those you have seen more publicly, such as the self-help kind of work. Some of you have been involved with me in other projects, other committees, consulting with other kinds of issues. And there's a place where all of these come together. And that's what science, policy, and politics is all about. You and I are living in a world that is changing very, very quickly. There's no secret there. My world is changing, your world is changing. But here's the thing, we're being asked to make choices and we're being asked to make decisions that we've never been asked to make before. And for the most part, we have been poorly prepared to make these decisions. We're being asked to embrace policies that we know very little about. We're being asked to enact laws that determine how we live our lives based on information that we really may not even understand. We're being asked to elect officials to represent us in the form of government that we have that are supposed to reflect our belief systems and our values. Well, how can we do that? How can we do that if we don't have the information? So the whole point of this series, and the reason I've developed it, it's based on a simple premise. The premise is this: when the facts are clear, our choices become obvious. Think about that. When the facts are clear, seldom do we need to be told what to do, because we say, of course, it makes perfect sense to do this thing or to think in this way. What I've found in my life is typically when the decisions are the most difficult is because I don't have all the information. You and I are being asked to make difficult decisions, and we're being told how to think. There's a battle playing out. You know that. I've talked about it in other programs, other episodes. There's a battle for our thoughts. There's a battle for our beliefs. There's a battle for our very humanness. High tech is leading us to believe that we are vulnerable, fragile, frail humans, and we must replace our natural, extraordinary biology with AI, artificial intelligence, computer chips, wires, chemicals. And I'm going to address that later in this series, as I have in other programs and other books. The point is that we're being asked to make the decisions based upon other people's ideas and the way they want us to think. So I am offering this to you. I wanted to bring this to you. There's no charge for any of this. I didn't want you to have to buy a book or go to a course, especially now. I'm going to date this a little bit. This is in the time of COVID, in the pandemic. Years from now, when the pandemic is behind us, you'll see this and you'll know when it was that this was created. But climate is especially important because it touches something so primal within each of us. We all love this planet. We all want a better world. We all want a good life for ourselves and our families. And we are passionately going about the things that we believe will lead us to that end. But what we're doing is based upon the information that we're being given. And this is what is tearing our families apart. I'm seeing families, I'm seeing husbands and wives separate and divorce. I'm seeing parents and children that can't find common ground. And it's tearing apart communities, it's tearing apart our society, it's tearing apart our nation, it is shattering our world. What is happening with climate? And it's causing such divisiveness. So I'm just gonna give an example. I live in northern New Mexico. There was a climate rally here not long ago. And the elders, people in my generation that were speaking to a younger generation, rather than inviting them to embrace data and make positive change, they incited them to become angry about the injustices that had been done based upon false assumptions of obsolete science. And those young people were then empowered to go and destroy property they felt justified in destroying the property that they felt was contributing to the lies of the climate change that they had just been told in this public forum. So this is an example of where I think it's so important. It all comes down to this fundamental question: how can we solve the problems if we're not honest about the problems? If we really want to solve these problems in a healthy way, we've got to be honest with ourselves. What are we afraid of? What have we got to lose if we are honest with ourselves about the change? Now, when it comes to climate, and I am really passionate about this, Earth is a dynamic system. And science is a dynamic system of knowledge. Science is designed to be constantly updated, and Earth is constantly changing. We are constantly having new research and new data that helps us to update what we have been led to believe about climate. So when someone in a position of power and authority says to me through the mainstream media, discussion is over, we can't talk about this anymore because the data is in, the discussion is over, finished. I am very suspicious of that person and their motives, because science is designed as an ongoing discussion. It's a conversation designed to be constantly updated and honed and refined based on the new data that comes in. So this is why I think this episode, this particular episode, is a very powerful episode, and this series is important because I am an independent researcher, an independent author. I'm not affiliated with any university or any academics, with any corporations, with any religions, with any organizations. I have nothing to lose by sharing with you what I have found as a scientist and a researcher. And when it's updated, I will update that with you. And when information overturns what I have said to you, I have no problem saying to you, I made the decision based upon what I knew in that moment. And as new information comes to me, I'm going to share it with you. This is how it works. And this is the healthy way for us to move forward in dealing with the changes that we see in our life and our world. So right now I'm a big Gregg on the screen. I have some images I'd like to share with you. So I'm going to become a little Gregg up in the upper right-hand corner of your screen so we can focus on the images. Near the end, I'll be the big Gregg again, and we'll have a little discussion, and let's see where we go from there. One of the best ways to understand our relationship to the climate of our planet in the present is to see how it fits into our relationship with the climate of the planet from the past. And this is one of the things that led me to become an earth scientist, to become a geologist, because I'm fascinated by the fact that we can look into the history of the earth, and earth will tell us her history in her own language if we have the wisdom to understand that language. And in the language of the southern Andes Mountains of Peru, Pachamama, Mother Earth, tells us her story. She reveals her past through records that can be read like you read the pages of a book. And as a young scientist, I was fascinated by this, not just because it's interesting, which it is, but because it also helps us to understand us. How have civilizations been influenced by climate in the past? When did great civilizations end, and when did they begin? And how does that relate to climate? What we find is climate change has driven the collapse of massive civilizations in the past. As the climate changed, food became scarce, competition became the way that the people were working, and it led to war. And the war is what ended those civilizations. That is important because we are in those cycles. And the question is, are we making the same mistakes as we have seen in previous civilizations? Can we recognize those? Can we make new choices? So one of the best ways to understand climate in the past is through what are called the ice cores. Every year, a new layer of ice is deposited in the cold regions of the extremes, the Greenland ice caps north of the equator and Antarctica south of the equator. And this is what the ice cores look like. I wanted you to see what an ice core looks like. I was surprised the first time I saw one. They're bigger than I thought that they would be. And from these ice cores, we can discover a whole lot of information. You would be amazed at what we can discover. And think about the reason. Every year when that ice layer forms, it captures little bubbles of air from the atmosphere. And in those bubbles of air, we can tell exactly how much carbon dioxide was in the atmosphere for that year, how much oxygen was in the atmosphere. We can tell if there were volcanoes on the planet because volcanic dust will be in that ice. We can tell if the pollen grains carried by the jet stream or by some other air current from one part of the world, we can tell what was happening in that part of the world because those pollen grains will be in the ice. We can tell what the temperatures were, how hot or how cold for that year, how high were the sea levels, how low, how strong was the sun, how strong were the magnetic fields, so much more. So you get the idea. So from the ice cores, we have a record of our past. Now, I want you to see, this is a close-up of what an ice core looks like. So you can see those vertical bands that you're seeing. Each band represents 1 year of Earth's history. The dark bands, obviously, something was happening. Maybe an asteroid struck the Earth and kicked a lot of dust into the atmosphere, or maybe it's the dust from the Sahara being blown by superstorms, or maybe maybe it was a meteorite, or fires, great fires swept the earth. All that's recorded in the ice. This information can be read like the pages of a book, and it's not surprised they're kept in what is called an ice core library. And there are multiple libraries. You're seeing one right here. So scientists can come and they can pull out these ice cores like you pull out a book in a library, although a lot of this is digital now. So they don't have to actually pull out this ice core any longer. All right, so let's get to the heart of this. What is the ice core telling us? I'm giving you peer-reviewed data. I want you to know these are not my theories. It's not my hypothesis. It's simply science that you rarely see in the mainstream. You won't see this in mainstream media. It's not popular. It doesn't support the narrative that is being perpetrated in the mainstream media. So I'm giving you the full references here. This is from peer-reviewed data that was published in the very prestigious journal Nature, volume 399. I'm even giving you all the researchers. Usually you'll have the name of one, and then it'll say ETAL, et al., which means, there are more. I want you to see all this here. There's no secrets here. What you're seeing is this. So let's start out. This is a graph showing data of temperature changes. Now, I'll be really clear. This is not absolute temperature. These are variations in the temperature above and below the normal from one ice core, and this is from EPICA, EPICA, in one location in Antarctica. It begins on the right-hand side, goes back 450,000 years before today. On the left-hand side is today, is present day. So all I want you to see from this, can you see that there are rhythms and cycles? And if you can, you're right on, because there are cycles within cycles. There are 5,000-year cycles. There's the 10,000-year cycles, 26,000-year cycles, 41,000-year cycles, 100,000-year cycles. And you say, well, Greg, maybe it's a one-off. Maybe this is an anomaly. What you're seeing in the green is a second ice core, a very famous ice core from another part of Antarctica, about 300 miles away from the Epica ice core. What you see in the green, it's the Vostok ice core. All I want you to see from this is, can you see how it agrees in general? The closely correlates. It parallels what you see. The green parallels what you see in the blue. So this is pretty good data. And the red at the bottom is very intuitive. What you're seeing, I'll show you, I think you can see the cursor from my computer here. What you're seeing is these are variations in temperatures. When the temperatures rise, like you're seeing on the green and the blue, what would you expect would happen with the ice? The warmer temperature would melt the ice would collapse, and look at that. This is exactly what you're seeing right here. And then when the temperatures are low, you would see the ice gradually build. It's exactly what you're seeing until they reach a warm place, and then the ice collapses. So this is, the red is the thickness of the ice compared to the temperature. All this comes from the ice cores. All right. So 450,000 years ago is how far back the Epica goes on the right. We are here on the left, right there. And I'm just going to say you are here. What this says, according to these the historic records of the temperature anomalies, it says that we should be in a warming period, and we are. I would be concerned if we were not having some degree of warming. I would say, why not? Because we're due for it, according to these cycles. So are we the warmest we've ever been? Not according to what these charts are telling us. We are warm, but there are cycles in the past where the difference in the temperature has been much greater than it is today. The other thing that I want you to note here is that when the warming does happen, or the cooling, this happens on both ends. When the warming happens, it's intense, but it's brief. It doesn't last long. It doesn't like drag on and on and on in a plateau. It's a peak, and then it's what comes next that's often the problem, because from the warming peak, we go into cooling cycles. Not necessarily an ice age every time, but definitely cooling. And it doesn't take much cooling to change the way that we live our lives, especially north of the equator, where most of the land mass is found, most of the population of the earth lives, and most of the food is grown north of the equator on the earth. So, here's the big question. In episode 1, what is the role of climate change in the world that we're seeing now? And I think we answered that. Are we the cause? This is the big question right now. Let's see what the data is telling us. We see these rhythms in the earth going back from here over 450,000 years before present. Scientists are in agreement, so this is not controversial what I'm going to say to you, that anatomically modern humans, you and me, the way we are right now, we showed up on Earth about 200,000 years before present. Now, I know there are other belief systems that give different dates and there are other interpretations. I am sharing with you peer reviewed science to honor you in this conversation. And I'm not discounting anything else that's out there. I'm choosing to share with you the scientific model so that we can have this conversation based upon facts rather than speculation. All right. 200,000 years ago, I'm going to show you where here's the line right here 200,000 years before present. So from that blue line to your left to present day, we have had the opportunity, the potential to contribute to climate change through industrialization that has happened in that 200,000 years. But look at this. Look at that blue line to the right. Science tells us that anatomically modern humans and modern industry did not exist during that time, but the cycles were still there. So, if we're honest with ourselves, are we the cause of the climate change because it was happening when we were not on Earth? We have to say that we are not the cause. So let's just be honest with ourselves. We're not causing climate change. I'll show you what is here in just a moment. And my sense is this episode may run just a little bit longer than the others, but not a lot. So please hang in there with me. But I want to be honest with you and share with you all of this data. Now, this chart that I'm going to share with you, you probably saw the film that came out a few years ago that was called An Inconvenient Truth. This is an inconvenient slide. All right. You're not going to see this in a lot of mainstream. It's based upon peer-reviewed data. You've got the source for it right here. So what this is may look a little technical, but I'm going to break it down really quickly. In the blue, what you see are the temperature, the rise and the fall of the temperatures. In the green, right below, what you're seeing is the rise and the fall of carbon dioxide based upon the data from those ice cores. Now, is there a correlation? Absolutely, there's a correlation. Right on, man. You can see a correlation. Correlation is not causation. All right. Just because the data correlates doesn't mean that one necessarily caused the other. All right. And what you're seeing here, I'm going to invite you to look closely. Let's take a look at one of these peaks right here. And I intentionally offset in this first line, I offset the red a little bit so that you could see where the peak is. I mean, if we move that over, you can see there's the peak in the temperature. And what you see is that temperature peaks before the CO2 is peaks. Even if I move that over a little bit, it would be like right here. The temperature rises before the carbon dioxide. Well, you say, well, wait a minute. I thought the greenhouse gases are causing the warming. I thought the CO2 is causing the warming. It's not what the data suggests. All right, I'm going to share with you what the data does suggest, but I'm just going to go through this step by step. You say, well, maybe that's a fluke. Did it happen somewhere else? Well, yeah, look at this. Everywhere where you see a rise in the blue, in the temperature, the CO2, it rises, but it lags. The temperature rises first and then the CO2 rises. All right. Seeing it right here. And I could go through all of these. I didn't, but I did enough to show you. Now, this one is interesting because look at this. The temperature is rising. Look at what the CO2 is doing right here. I'm just going to back off. There's the CO2. It's actually dipping. The carbon dioxide is low and the temperature is rising. All right. And look at these big peaks over here. Here, the temperature is rising. CO2 is rising, but it lags. The temperature is rising, the CO2 lags. Look at this. You see it right there. It's happening throughout our past. Now, this surprised a lot of scientists. There's a reason for this. And I want to be really clear. This is a tricky conversation. It's delicate. This is not climate denial. It's just the opposite. The fact is, climate change is a fact. We need to adapt to climate change. We are not the cause of the climate change. Are we contributing? We have to say that we're contributing because we are kicking carbon dioxide into the atmosphere. Is carbon dioxide causing the warming? This data says that it's not. All right. Now I'm going to show you what that means here in just a moment. But let's look at this. Here we are right here. I made a different color line on the far right. Here's present day. And look, when our warming began, all right, so here's our warming beginning right down here, and you're seeing this warming. The same thing is happening. The CO2 lags. Now, there are charts and graphs out there that are showing you 10-year histories of the Earth or 80-year histories of the Earth. Mother Nature, geology does not work in 10-year or 80-year cycles. Mother Nature works in vast cycles of time. And I think it's very disingenuous to take that data in these snapshots out of the context of the big picture. That's called cherry picking the data. And there's some people that are really good at doing that. So what you're seeing is we are in a warming. There it is right there. The warming began before the CO2. And it's not your imagination. I want you to know, I want to show you the chart and where that came from. Here is the peer-reviewed data. Here are the scientists telling us this. Here's the title, Vostok Ice Core Climatic Response to CO2 and Orbital Forcing Changes Over Last Climatic Cycle. This is one of the reasons that you don't see this in the mainstream. Look at the title of this article. I mean, who has a beautiful hardbound copy of this article on your bedstand for light bedtime reading, like I do? They're very complex articles, and that's why they're often published in obscure journals. You don't see a lot of this in the mainstream science, but look at what it's saying. Look at this. This is a direct quote. When going from interglacial to glacial conditions. I'll stop right there. What does that mean? Glacial conditions are when the glaciers are prevalent on the Earth. We are not in that now. We're in between. So we are in the interglacial. So when going from where we are now, from interglacial into glacial conditions, now look at this. Look at what this says. The change in carbon dioxide concentration actually lags the change in the air temperature. All right, they're telling us, right? This is rock solid, hardcore science. These are not politicians. These are not people who have an agenda, a political agenda, or a domestic agenda, or an economic agenda, or a religious agenda. These are scientists doing their job. The carbon dioxide lags the change in the air temperature, and you just saw that. You saw that in the chart. All right, so I'm going to move quickly. If the carbon dioxide is not the cause, what is? Scientists have known for most of the 20th century the answer to this question. A lot of scientists don't like this answer, but they're now being led to a place where they've got to embrace what this answer is saying. You know, we ask science to tell us who we are and about our relationship to the world, and science does that. And sometimes there's some scientists that don't like the answers and push back on those answers. There was a mathematician, his name was Milutin Milankovitch. You know where this is going if you are familiar with Milankovich's cycles. He identified cycles that are very probably the trigger for the climate change. Now, when I was in school, I have to say this, back in the 1950s, 1960s, early 1970s, when I was in school, I remember a colored picture in my geology book of the sun in the middle of the page, and then Earth making an orbit around the sun, which it does, but that orbit being a perfectly circular orbit, and Earth looking exactly the same orientation everywhere in that orbit. That simply is not true. Earth does a dance, as Earth orbits the sun. And that dance has three primary movements. Those movements change our relationship to the sun. And that is what scientists now suspect is the trigger for climate change. Here's what I mean. Milankovitch cycles. The first of these movements is called the precession of the equinoxes. It's a 24 to 26,000 year cycle, huge cycles of time. Precession, I'm going to invite you just to hold that in mind for a moment. The second is one of the biggest, probably has one of the greatest influences, is caused eccentricity. So what you see here, you see the blue line that depicts the Earth's orbit. Here's the sun in the middle. And you can see that sometimes we are, if we were here, we're closer to the sun. Sometimes we're further away. All right. That means different times in the orbit are relative to where the sun is. And those differences range from 100,000 years to 413,000 years. So that is the eccentricity. And the third is what's called obliquity, or simply the tilt. And this is about a 41,000 year cycle. So all I want you to see from this: precession, eccentricity, obliquity. Here it is graphed on a chart: precession, eccentricity, obliquity. And what you're going to see right at the bottom is the warming and the cooling of the Earth as it relates to these cycles. So here's how this appears to work. When one or two or some combination of these peaks line up, Earth goes through some climate change. And it happens all the time. Sometimes it can be simply this eccentricity seems to be driving a lot of the effect. So let's look at what we're seeing right here. Let me just show you. Right there. Okay, what you're seeing, I'm going to back it up so you can see it. The peak of that blue is lining up with the peak of the red right there. Can you see that? All right. And so when precession and eccentricity are lined up, look at what happens down here. You've got warming. You say, well, Greg, maybe that is a one-off. Maybe it's a fluke. Well, look at this. Here's the right in the peak of the eccentricity. I'm going to back this off so you can see it. There is also the peak of the obliquity right there. And you're also seeing the peak of the precession. So all three line up right here, and you've got some warming. This happens all the time. And this appears to be what we're experiencing right now. So where are we today? Where are we right now? Here's a 1,000 years ago. Here is present day. And look at what's happening. I don't know if I didn't draw a little line there, but here's us right here where the cursor is. And look at how minor our eccentricity is compared to where it's been in the past. We are experiencing relatively minor climate change. Now, it's big to us because we're not prepared for it. It's big to us because it's different from what we have been led to experience in the past. We've been led to believe that Earth is a static system and that the seasons always happen at the same time. The climate is always the way it is. And when that varies, we think something is wrong or something is broken. And that belief can be hijacked and used as leverage for political agendas. All right. I just want you to be aware of the truth of our relationship to the climate. We definitely need to go green. Don't get me wrong. I want to be very clear. We need to go green. We need to stop burning fossil fuels. What I'm sharing with you is not an excuse for the abuse of fossil fuels. We need to go clean, green, sustainable. I'm going to talk about it in just a moment, but that's the question we're answering right now is, are we responsible? Did we cause the climate change? And are we causing the climate change? So are we causing this warming? As a scientist, I have to say we are not the cause. The data simply doesn't support that. It suggests that the Milankovitch cycles are the initial cause. Now, here's how this works, and I don't want to get really complex, but I want to be very clear. It appears that the Milankovitch cycles begin the climate change. So they trigger the warming, and that's why the warming happens first. And then you see the CO2 start to rise because when the warming occurs, it warms the land, it warms the oceans. When the water is cool, it holds more carbon dioxide. As the oceans begin to warm, they begin to release carbon dioxide into the atmosphere. And we are now contributing in that part of the cycle. We are contributing to the carbon dioxide that is naturally released into the atmosphere through these cycles. All right. So, to what degree are we contributing and how can we change that? That's other episodes. I'm answering the question right now. Are we the cause? We're not the cause. The data supports. So, where do we go from here? We've just covered a lot of ground. I knew I moved quickly. Our episode's gone just a little bit longer than it typically would. So, what I'd like to do is let me come back to the big Greg and let's see where we go from here. What does it make sense to do from this point forward? We began this episode by asking a single question. Are we the cause of climate change? Are we the cause of global warming? You and I together have explored peer-reviewed data telling us that we are not the cause. The climate change was happening long before humans ever appeared upon Earth. The data also suggests that we are contributing to the greenhouse gases that are correlated to climate change. But are those gases actually worsening the warming? We're going to explore that answer in future episodes. But here's what I want to say about the climate change right now. Climate change is only a problem if we're not prepared for the climate change. There's something called normalcy bias in psychology, where when an individual is confronted with a change that is so massive and it represents such a perceived obstacle, the tendency is just to discount the change, to try to live life as if that change were not occurring. We're experiencing normalcy bias when it comes to climate change because we are being asked to continue living just the way we've always lived in the presence of extremes in weather and local weather and rain and snow and heat and cold and floods and ocean levels. It makes sense to expect those extremes because of where we are in the climate change. And if we adapted accordingly, there would be much less suffering. And I believe that we would have a much different experience of what the climate change is leading us to experience right now. If we're honest with ourselves, we have everything we need, not just to survive, but to thrive, to transcend and become better people, create a better world. We have all the information. The question is, are we willing to embrace the information that we've asked science to provide us? That's what this series is all about. And in the next series, we're going to pick up right where we leave off here in the next episode. And we're going to begin talking about the forms of energy that are available to us. What would you do if I said to you that there's a form of energy that produces zero greenhouse gases, burns zero fossil fuels, that is made from a substance that is available in the earth abundantly, inexpensively on every continent of the earth? It cannot be weaponized like uranium is as it's made into plutonium. It cannot melt down like a Fukushima reactor. What would you do if I said we have that available? We've already used it and it's been available for over 70 years. You probably ask the same question that I do. Where is it? I invite you to join me in the next episode, and we're going to talk about that and much more as we continue our conversation of science, policy, and politics.